Okay, good evening everyone, and welcome to class. So this is the 14th session of the data science program, and we're going to kick off or pick up from where we stopped in the last class. So yesterday's class we looked at exploratory data analysis, right? We looked at the different techniques that we can use, or the steps rather, in EDA. So let me just, or rather in data analysis generally. So we looked at how we can acquire our data and then load it into Pandas using Pandas function, right? We also looked at how we can explore and understand our data. So we looked at some of the functions and methods we can use to explore and understand what data you're going to be working with. We then moved on to data cleaning, right? So we were looking at how we can clean or approach data cleaning in Pandas, right? So I highlighted several data cleaning techniques. So we would pick up from there, right? And move ahead and look at how we can perform EDA. So today we'll primarily be focused on exploratory data analysis. I'm hoping this class doesn't extend so much, right? Because I'm looking at starting data visualization today because we are going to be integrating it with EDA. All right, we're going to be integrating it with EDA and then complete or conclude data visualization in the next class. And by Sunday next week, we should start machine learning. So that's actually my plan. I hope it actually goes according to what I've mapped out. So let me just reiterate. We'll pick up from where we stopped in the last class, EDA, and then introduce data visualization, right? And then conclude with data visualization in the next class, which is on Saturday. And by Sunday next week, we should start with machine learning. So next week is going to be our week 8. So after week 8, we basically have 4 more weeks to go, like 8 more sessions. So we have to wrap up within we have to utilize the remaining time to cover everything that we have to cover, right? Because our project will be starting by 10th week. So by 10th week, I would be giving out the project. So we're going to be doing that alongside our classes. So when immediately the project commences, assignment would be halted, right? We're going to stop at giving assignment, and the focus will now be on your project. So that's basically what we have to do moving forward. All right. So okay, yeah, that's it. I'm just going through the group looking to see if there's anything I need to pay attention to. All right. So yeah, we're going to be kicking off right about now. So yesterday we looked at some few things. So we looked at how we can load our data, customer bookings data set, right? Then moved on to understanding your data. It gave us different functions that we can use to achieve that. And we literally just walked through data analysis in Pandas, right? So I believe from yesterday's class, you should have an idea of how you can approach data analysis. If you didn't attend yesterday's class, do well to go through the recording. The recording is already available. So do well to go through the recording. And I remember that our assignment, I said I was going to drop a poll. Yeah, I've not forgotten. So once we are done with this week's class, the poll is going to be made. I'm going to drop it in the group chat. And I'm looking at Friday or Wednesday, either Wednesday or Friday, right? So if we're going to go with Wednesday, then it's going to be we're going to go through the week 2 to week 6 assignment. If it's going to be on Friday, then we are going to have to include week 7 assignment. So I'm still looking for a date that will be convenient, right? That I'll be free so we can have enough time to go through. It's not compulsory. The recording will be made available, but not on YouTube. I'll just send the recording directly to Telegram, the Telegram channel. So you can as well go through it if you miss the class. So, but it's going to help you, especially for those that need to know where it is they missed during the in the assignments. So yeah, that's it. So let's get back to today's work. So I looked at so many things yesterday. We even talked about this should be three. Let me just put it this way: basic type of analysis. All right. So we looked at types of analysis, looked at univariate analysis, bivariate analysis, multivariate analysis. So I explained what these different analysis focuses on, right? So remember, we also talked about univariate data, bivariate data, and multivariate data, and we explained that as well. So I believe you still remember all we talked about as regarding types of analysis and types of data sets. So we looked at how we can clean our data, right? And this was where we um, focused on mostly. So we looked at how we can handle missing data using drop or replace. So I gave us instances of how to do this. So I also looked at how we can remove duplicate value with functions. So we basically just looked at this two yesterday. So I think I also showed you what inconsistent data is, an example of inconsistent data and what they look like. All right. So we would also move forward. We also look at how we can handle outliers, right? And when we get to machine learning, we can just figure out how we will see how to like do this encoding categorical variables and normalizing data. So that's going to be it, and we are going to start from from this data cleaning and then wrap up with EDA and look at how we are going to probably introduce data visualization into this class because I don't want it choked up in the next class. So yeah, I believe I've been able to give a summary of everything we've done and what we have to do. So hope everyone got what I said and everyone can hear me clearly and we are good to go. Okay. All right. That's fine. So let's kick off. Let's go straight to the next thing here. So we've looked at okay, we've not looked at outliers yet. So let's quickly see. Although there are different statistical techniques, but I'm just going to take us through the basics first. I'm supposed to start with EDA straight away, but so before we move on, I just want to assess our knowledge on outliers. Does anybody know what outliers are? Can someone just tell us what outliers are before I proceed? All right. All right. So I can see some responses. Outliers are numbers of variables very far apart from others in the same column. Like age of children between below 18, then getting 50 years. All right, to that point. Okay, great. Yeah, I think we kind of have an idea of what outliers are. So basically, outliers are anomaly in a data set. So it's basically um, data points. There are data points that differ significantly from other observations in the data set. So if you have, like, let's say, as someone said, age of let's say you're having, so let's say, salary of a particular group of people, and you're having something like 200K, 300K, 500K, 600K, 150K, 200K, 250K, 350K. You're having like there's this the different data points are within a very a specific range, a closed range. So then you now see another record or another like data point that is 7 million naira, right? So that in that case is an outlier, right? Because it differs significantly, right? Normally variables are supposed to differ, but this particular data point differs significantly. So the outliers are usually something you need to handle. You need to know why you are having this kind of value. Because for instance, if you are computing the mean salary for a particular group, and then you introduce that 7 million naira, use it to calculate it, that outlier itself is going to affect the mean. So it's going to give you a skewed result, right? And you might have a wrong interpretation based on the mean you have, right? So that's why it's necessary to like spot outliers in your data set and handle them. So the most common way to handle outliers is basically by using the IQR method. It's called IQR method. Let me change it to Markdown. So there are other methods, but let's just use IQR, which basically means quarter range. Okay, interquarter range. Let me know this one. So this interquarter range is basically a statistical concept that is used to measure the spread of data points in your data set. So this has to do with numerical data set right now. So when we talk about outliers, it's mostly numerical data types. So interquarter range is basically used to measure the spread of your values in a particular data set or in a particular variable. Let's just use a single variable, right? So for interquarter range, we have three quartiles, right? We have the 25th percentile, we have the 50th percentile, and we have the 75th percentile, right? So that's basically, if you are not familiar with this, that's fine. That's actually fine. This is statistics, so we're not going to go in depth into statistics, right? So, but this is just a concept that we're going to be like borrowing from statistics to handle outliers. So for outliers, we have three of them. We have the 25th percentile. We have the 75th percentile, and we have 50th percentile rather. So the 50th percentile is basically the mean, so it corresponds to the mean, while the 75th percentile. We have three of them, so they are usually called Q1, Q2, and we have Q3. The reason why I'm introducing this is to show you how you can actually handle outliers. So you use your interquartile ranges, your interquartile range to handle outliers. So basically your 25th percentile mean that it basically corresponds to all your data points that fall it corresponds to the range in which 25% of all your data falls into, right? So if you bring 25% of your data, they fall into that particular range, right? While your 50% corresponds to the range in which 50% of all your data, that is half of all your data, fall in that particular range. Why the 75% basically mean that it's the range where 75% of all your data fall into. So we are going to look at how we can determine outliers using this percentile method here. So we have a formula for it, right? We have a formula for it. So the two formulas that we are going to be using are these formulas here. So we have it to detect values that are outliers. We have this formula Q1 minus 1.5 times IQR. So this formula is used to detect values that are too low. Why this formula here? Q3 plus, I think it should be plus 1.5 times your IQR. So this particular formula detects values that are too high. All right. So these are the formulas you're going to be using basically to identify outliers in your data set. So how do we now? The question now is how do we implement it in Pandas? So let me have this marked down. So to get your IQR as well, I think I didn't write that one. To get your IQR, the formula is Q3 minus Q1. So this formula to get your IQR, so you can just slot it into this place here. So now, how do we implement this in Pandas? We have our data frame already here, DF. We have our data frame here, and we want to perform outlier analysis on our numerical data set. So let's pick this purchase lead here. All right, let's pick purchase lead. So I'm going to say purchased. Okay, the column was even. Come on, let me change this to you. So these are purchase lead. These are purchase lead column here or variable. So there's a simple way to have an idea the ranges or the values that are in this data set. So there's a formula called n largest. So this is, I'll still go to the IQR method, but I just want to show you something quickly. So we have n largest function here. So what this n largest does is that it returns the first n rows ordered by columns in a descending order. So if I say int, right, the int is going to be a number. If I say I want to get the 4 largest values, right? 4 largest values for this purchase lead. So it's going to return this is the index here. So you don't look at this. These are the values. So you can see that the highest value here is 868, followed by 704, followed by 641, followed by 632. So you can see that there's actually a close gap between our values here. Let's say 10 largest values. Okay, we have this 8, 6, and going down to 5, 7, 7. So from this, you would start to realize that you probably don't even have outliers in this particular variable. But this is not the best way to confirm outliers, right? But this is the first step that you can do. This is the first thing that you can do to determine the ranges, the value ranges in that particular variable. So you can use your n largest to get that or to determine that. So once you do that, you realize that, oh, the values don't significantly differ, like the highest value. Normally, if there's an outlier and you use n largest, you see that the highest number here might be something like, let's say 5,000, and the number that follows will be like 700 and then 600. So from this, you see the disparity, you see the difference in the gap between the largest number and the preceding number. So you can now like assume or conclude that, okay, this is an outlier, right? And then you can now start performing outlier analysis and then removing the outliers from your data set. But let's just continue. So let's just check the other numerical variables we have here. So we have the column. Let's come here. Say info. Okay, so we have length of stay, flight hour, flights. Let's just check length flight hour first. Okay. So we're having similar values. Let me see. Smallest. All right. So this is the function you can use to just access your data to know the largest value and the smallest value. Here you can see basically there's no outlier here from what we are seeing here. So check. Let's check purchase lead. Okay, that was one we checked before. Let's check length of stay. All right, so it's close range. So actually in this data set we don't have outliers. So but I'm just showing you how you would approach it, assuming there are outliers here. So you go through all the numerical variables and then assess them to be sure that there are no outliers. So outlier analysis is the first thing you do before you start performing EDA. Actually, outliers is part of the data cleaning process, so you definitely have to do that as well. So let's just go back to this IQR. So let's just assume that this our data probably potentially has an outlier. How do you fix it? How do you remove those outliers? So let's go back to this interquartile range that we've explained already. So to get your IQR, you need 3 values. You need to get your Q1, you need to get your Q3, and you need to get your IQR. All right. So these are the 3 things you need to get. So let's pick up a particular variable. Let's just continue with purchase lead. So to get your 25% percentile, you would use this particular function, quantile, and then you come here and say 0.25. So this basically represents 25 percentile. right? And you just come and pass it to Q1, just let's call it Q1 here. So if you check this function, you see that it returns value at a given quantile over requested axis. All right. So it's as simple as that. So you do for your Q3 as well. Q3 df purchase lead quantile, and you put 0.75. So you've gotten your Q1 now, you've gotten your Q3. What is remaining is your IQR. So your IQR formula is from what I said, it's Q3 minus Q1. So if you run this, you should get all your values for Q1, Q3, and IQR. So if you print out Q1 here, let's come and say 25th center. So you can see now that we have different 3 values that correspond to our statistics. So we have 21 corresponding to our 25th percentile. We have 115 corresponding to our 75th percentile, and we have 94 as our interquartile range. So these values are gotten from your purchase lead variable. So this is what we're now going to use to filter out any potential outlier. So how do you do that? You've gotten your value. So the next thing to do is to determine your lower bound and higher bound. So the formula I gave you here, Q1 minus 1.5 times IQR is used to determine your lower bound or to get your lower bound value. So I'll come here and say Q1 minus 1.5 times IQR, and then upper bound is going to correspond to Q3 plus 1.5 times IQR. So you bring the both of them here. Lower bound All right, so this is our lower bound and upper bound, right? So we'll now use these values now to filter out outliers from our data set. So how do you do that? So it's your normal filtering. So to filter that, you come and say df purchase lead greater than equal to lower bound, and df purchase lead less than or equal to your so if I run this, should give me an output. Why did I miss it here? Outputs, background. Um, okay, so I need to put this. All right, so yeah, this is going to be the output we get. We're going to get a Boolean mask, basically giving us either true or false. All right. So to get the actual value, you just come and then filter out the or convert it basically to your actual data set by using your DF, just enclosing it in a general bracket. All right. So once you do that, you should get the data set that corresponds or that removes the outliers. So you can see we have 45,833 rows here, and then we still have our 14 columns. So this is just the general approach to removing outliers. I know it's a lot, right? It's actually quite some steps, especially for those that are new to statistics and are not familiar with interquartile ranges. So I actually I initially didn't want to go through these interquartile ranges, but I just wanted to introduce it to you so you have an idea of what interquartile range does. Anyways, I don't spend much time on or dwell more on this, but this is just the one of the approach on removing outliers. So this is one of the approaches we use in removing outliers. We use interquartile ranges, and we will define about 25th percentile and 75th percentile. So the 50th percentile is the same thing as your mean, basically. All right, it's the same thing as your mean. So you will define that and use it to compute this particular formula here for higher bound and lower for upper bound and lower bound, and then you can now use it upper bound and lower bound to filter out those particular data sets that are too low and that are too high, basically, right? So that is what we do that is what we did in this particular place. We are filtering. Let me show you this. Yeah, we are basically filtering the data set that are too low and that are too high according to this our formula here, right? So and then we're going to get a new data frame that has the outliers for that particular column removed. So what you do normally is to do it for each of the variables that have outliers. After you've analyzed it and you've checked the data set, you've checked the n largest and n smallest, you've seen that the distance between the highest number and the lowest number is actually a lot, right? So but there's a better way to do that, which is via visualization. Visualizing your data, you're going to see outliers at a glance. It will help you to know that okay, this particular variable has outliers, so you don't need to go through all these things and you can just simply filter them out. All right, but this IQR is a method. The reason why I even brought this was because someone asked this question in yesterday's class. All right, so this is still on data cleaning, but we'll be moving on to EDA, and EDA was supposed to be the focus on this class, but I just thought to just say a little on outlier detection. But normally, I was going to still treat outliers when we start visualization or when we go in depth into visualization. So in our next class, we're going to look at how we treat outliers using our visual techniques. All right, but just keep this one at the back of your mind. So let's move on to what we have for today. So we'll be doing our exploratory exploratory data analysis. So we've moved from loading our data to exploring our data to cleaning our data. Now we're going to actually now perform analysis, and we're going to like um, gain or glean insight from our data basically. So in exploratory data analysis, there are a lot of things that you can do, right? There are tons of stuff. There are tons of stuff to do in exploratory data analysis, but based for the purpose of this class, we're going to focus on the most relevant functions, right, or the most relevant concept, or the most important concept that you will mostly be using when doing EDA. So we have what we call group by, right, and aggregation functions. So these two combination. This combination is basically what you'll be using when performing EDA. All right. And also visualizations, right? We have histograms, we have scatter plots, we have box plot. So all these things are just part of visualization techniques. So you're going to understand it better once you start data visualization. So we also have things like coefficients, correlation coefficients, and the function you can use to get the correlation coefficient, and which data type you should perform correlation coefficient on, or correlation on, right? And you also look at how you identify trends and relationships between two variables, how one variable affects another variable, and the likes and all of that. So that's basically, those are things you basically be doing in your EDA, and there's really no defined path to follow, right? But there's a kind of general structure, right? Like you are basically trying to glean insight from your data. So these are the common tools to use in Pandas. Also, we are working on Pandas, and so these are the common tools to use. So you determine what will determine the tool to use will be based on what you want to do. All right. There are some things, or there are some analysis you'll be doing. You'll probably not even use correlation. All right. So there's some analysis you'll be doing. You probably not use some of the techniques you're going to use. So it depends on what you are doing or the kind of analysis you are doing. So the best thing is to understand your data and to understand exactly what you are trying to achieve. So let's just go straight ahead to our EDA. Now, for the EDA, well, first of all, we assume that we've cleaned our data. Our data is good, right? It doesn't have any flaw. It doesn't have any issue at all. It's consistent. All the missing values have been dealt with. The outliers have been removed and everything. So after you've done all those cleaning, now you can now start afresh to look at your data generally again. So after you clean your data, you can now come back and now start checking your data. You can say, let me get the shape of my data now. So my data shape is 49,000. So this is basically after you clean your data. So most times when you clean your data, you don't expect it to still have the same number of rows as it was initially before cleaning. So most likely your data set would have changed shape. So even during cleaning sometimes, you'll probably remove some columns, right? Because there's some columns that don't have any meaning, right? There's some columns that don't have any meaning. So you just drop them during your cleaning process. So it might affect the number of columns you have moving forward. So, but in this case, the number of columns is still retained. So we have 14 columns as we had, and we also have 49,000 rows. So you can see that the cleaning process actually affected the number of rows. So that is basically how you start it. So you now start checking your the columns that you have. Let's say we have this number of columns. So normally, when you are given a problem, analysis problem, you should be told what to do. Like what the manager, let's assume the manager is the person giving you the task. So the manager should expect something from you. Let's say the manager just wants to know the average flights in a day, All right, or the manager wants to know how many passengers, or which day of the week have the highest number of passengers, right? So there's some questions that will follow your analysis, or that should follow your analysis. So those are the things that will inform your that will determine the direction you go during the exploratory data analysis, all right? So, but in this case, I'm just going to just go back and forth just so you have an idea of the things you can do in EDA or while doing your own EDA. So now let's look at different data we have. So we have this info here, df.info. So we have 14 variables in total. So now we have number of passengers, we have sales channels, we have trip type, right? We have purchase lead and the rest. So now we want to start by knowing which particular sales channel. So the first question here now is, let me just come here, put it. First questions. Which particular sales channel was used the most? All right, so this is a potential question you can get. All right, let me see. Let me just try to get some possible questions, or questions from this data. So you can say which particular day had the most flights. Which particular day had the most flights? All right, that's another question. So we can come and say okay, we can say which sales. Okay, we've gotten this one. Trip type. We can say which particular day of the week had the highest flights. Which particular day of the week had the highest flight duration? These are questions. I'm just bringing out questions from this data that can guide us to in our EDA. So let me see. Let me even see the data so I can. DL.H. So we have trip type, we have purchase lead, we have length of stay, we have flight hour, we have flight day, we have this, we have booking origin. Okay, we can say how many complete bookings did we have? All right. How many did we have? And which sales channel had the highest number of complete booking? All right. So we can go on and on to get several questions from this, but let's just stick with these ones that we have already. So we are going to be guided, our analysis is going to be guided by these questions now. So we have this first one, which particular sales channel was used the most? So when you see this kind of thing, the first thing that you should think of is, okay, we are talking about a particular variable. So you ask yourself, do we have that data available? So if you go through the data, you'll see that yes, we have the variable in our data. If you don't have it, you have to refer back to your stakeholder or the person that you are reporting to, that, oh, we actually need this part, we actually need data to answer this question. So they can now figure out a way to maybe probably grant you access to the database to get that particular data, or what have you. So, but in this case, we have the particular data available to answer that question. So sales channel is here already. So you can now like isolate the variable and then perform univariate analysis on it. So what you do here is that you want to know the different sales channel we have. Like that's the first thing you're going to have to do. You say, okay, getting the sales channel categories. Okay, so in the last class, there was a function that I showed us that would help us get the unique categories for a particular variable. So can someone just remind us, just type out tell us the function that we use to do that. So we want to get the unique categories for sales channel. How do we do that? I think I mentioned that in yesterday's class. Okay, I'm seeing n unique. So n unique basically will give you the number of unique values actually, but I want to know the actual category names. All right, I don't just want to know the number of unique categories. I want to know the actual categories names. So the function for that is your unique function. So I'll come here and say unique df sales channel. So what I'll do here is I'm just to make things easier for me. I'll just do sales channel. I'll just say sales and say df. So to avoid repetition of this lengthy column name, so I'll just come and say sales.unique. All right. So if I come here, you see that we have just two categories in this our sales channel, right? So this is like pretty much straightforward. So since we have two categories, you can just use your value count function to get the total number of rows for each of these categories. So the way to do that is by using our value counts. So come here and say value count. With S. I don't know why I'm always forgetting whether there's an S here or not. So you can see that we've used this value count now to get total number of rows or total number of passengers that use internet and those that use mobile phone. So I really don't know. We just ignore these categories for now. But basically, we have 43,000 passengers using this particular sales channel, and then we have just 5,364 passengers using this sales channel. So based on the problem or the business problem, we will now start asking questions as to out of these 43,000, how many of them had successful booking? So that's a potential question that we can have. All right, so that include that. Okay, so that's the last question here, right? We're going to handle that as well. So we can okay. So this is basically how you get your total number for each category. So if you want to get it as percentage, and just come here and say normalize equal to true, and then you have the percentage values. So I think all right. I just want to check something here. So round and then we have, let's say, 2. So now you can have a percentage like so you can see we have it's 9.1% for internet. So out of all the passengers, it's 9.1% of them use this particular sales channel, and then 10.9% of them use mobile channel. So this is actually you performed an analysis actually. So this is something that you can report. You can now present this in a chart, all right, and then show it to your manager as requested and say, okay, out of all the passengers that we've had so far, majority of the passengers resorted to using internet as their sales channel and for getting their ticket basically, while just minority of them used mobile. So this is an analysis on its own. So you can just, if this is what you need to do, you actually done. So what you need to just do going forward is just to present this in a graph and then report it and present it to your manager. So, but basically you would not see something like this alone. You will have other questions or other questions that will be based on this result or this answer that you have here. So you can see here that we can now see how that we have how many complete bookings did we have, right? And which sales channel have the number of complete booking. So you can now see that we are now having a relationship between two variables here. We have our sales channel variable and we have our complete bookings variable. So in this case, we are going to be performing a bivariate analysis, all right? We're performing a bivariate analysis here, but for these ones that we have here, these ones are univariate analysis. So this analysis I perform here, as simple as it is a univariate analysis, and it's something that you'd actually be doing when the data makes sense. You realize that the insight you are getting will be very meaningful and helpful. The reason why this is just looking like it's not, these things right now really mean something, and data that actually means something. You're going to start seeing the importance of, or you're going to start seeing the value basically of the analysis you've done, right? So let's just continue with the questions we have here. So we can also ask this question: what particular day had the most flights? So this is also a univariate analysis. We have to look for the variable that has this particular that can answer this question. So looking at our data type here, we have these different variables, and we have flight day here. So this variable can be used to answer our question. So you isolate it and pick it. So let me just copy that. So I'm going to come here and say df, let me just say day. We have flights. Boom. All right. So the reason I'm passing this into a variable is because I don't want to be retyping this and retyping it because it's lengthy. We have day here. So I want to see the unique. So this is days. These are days. So obviously you should already know the unique. What is happening to me? Unique. So you can see that we have Saturday, Wednesday, Thursday, Monday, Sunday, Tuesday, Friday. We didn't handle missing data for this particular variable. So you can see that this should not be happening. You can see that this should not be happening, right? Because we've assumed that we cleaned our data here, so we should not be seeing any N here. So, but let's just continue with that. So we have Saturday, Wednesday, Thursday, Monday, Sunday. How many do we have here? That is 7. Okay, 7 complete. So to determine or get the day with the highest number of flights, you can just come and say day dot value counts, and then normalize equal true. So that is if you want to put it as percentage, right? So I can come here and just put 1 there. So from this now you can see that Monday here has the highest percentage. So let's remove this first so that we can see the number first. So they are actually very close. They are very close. So they don't significantly vary in the number of flights they have, right? So but based on what we have here, Monday has the highest number. It has 798,000 number of wait, why is this even very first? Okay, I just want to be sure what's happening here. Okay, just give me some minutes. Let me open the attendance quickly. All right, so the attendance is open now. Okay. So the attendance is open now. You can actually go and mark the attendance. So I'm wondering why we are having these values here. So let me see. Sales. Okay, I think I know why. I multiply it times 100 here. Thank you, Justice. I multiply it as 100, so that's why I'm getting those inflated numbers, because the total number of for each category should not be more, it should be equal to the number of rows. So I was looking at it and wondering why we are having these higher numbers here, right? So I did that just because of the percentage, right? So we can have like you can have it in a better format. So these are the different categories and their values. So you can see we have Monday, Wednesday, Tuesday, Thursday, Friday, Saturday. Now you can now know the day with the highest number of flights. So you can say Monday is the that, and then Saturday is the one with the least number of flights here. So that is how we can perform univariate analysis on mostly categorical variables. So value count is a very important function that would achieve that. So we have which particular day of the week had the highest flight duration. So now this is a univariate analysis actually. Univariate analysis actually. We're going to be looking at two variables here. We're going to look at flight duration, and we're also going to look at day of the week. So now this is when we're going to start introducing what we call group by function. All right, group by function. So using group by function. So your group by function is a very, very important function. We use it in EDA, and we use it mostly when we want to group your data based on a particular column, right? So let's say you want to, and we use it alongside aggregate functions. Remember I told us about aggregate functions. Who can remind us of some of the aggregate functions we have or that we've spoken about in the previous class? Okay. Someone said mean. Okay, max, mean. Minimum. Okay. All right. So we are correct. All right. So let's just quickly look at it. How we can use group by functions. So our group by functions, you can use it to group a particular numerical variable based on a categorical variable. So in this case, we are looking at which day of the week had the highest flight duration. So we have two variables here. We have day of the week. That is days, right? Days. Day, right? We have this one, and then we have df dot flight duration. So we have this particular column as well. So I don't know why I haven't just 5.5.5.2. Let me see largest. Okay, we have other things here as well. That's great. So we have flight duration and we have sales. So let me just assign this to a variable. Duration. Or let me just say door. So the purpose of this is just to avoid typing all the long stuff. So now I want to aggregate my flight duration based on the days. So if I come and I say df dot this for flight duration and I use our mean, I'm going to get a single value, right? So this single value is corresponds to the mean of my flight duration for all the records that we have, all the days that we have. It aggregates the mean for all the days. It does not put the days into account. It just aggregates every single thing, right? So if you want to like consider a particular categorical variable while aggregating a numerical variable, you would introduce your group by function, right? And how you do that is by saying df dot group by, or typing df dot group by, and then what you have here is your categorical variable. So we have sales, right? And then we have our, this one should be your, okay, this will actually be your variable name without df. So in this case, you should have sales, what was sales channel, right? But let's work with days first. Let's have days. So what exactly is the day name? Flight day. So I'm going to copy this and paste here. So, and the numerical variable we want to aggregate with is a flight duration. So I'll come here and just copy that and paste here. So if I run this, I'm going to get something like this. So now I'm grouping my mean, the mean flight duration by my flight days. So I'm not getting a single value for flight duration again. Now I'm getting 7 values according to the different categories for my flight duration. So with this, we've actually been able to answer this question: what particular day of the week had the highest flight duration? So if you come here, you can see that we have, let's look at them here, and 7.379 should be the highest, right? And that's Sunday. So Sunday is the day of the week with the average highest flight duration, right? So this particular analysis now has been able to answer this question here that we have here. So we used bivariate analysis and the group by function. So the group by function always goes with the aggregate function. So in any aggregate function, you can use mean, median. Let's use another one here. Let's say mean. You can say use median and mode and all of that. So you, depending on what you're doing, you can use this particular group by function to achieve that. So let's change it to sales purchase. I don't know if I got this correctly, but let's see. Sales purchase. Sales, sorry, is this? Sorry, is it purchase? Sorry, sales channel rather. The truth is that I'm not just filling it today. I'm not just filling it today, but just have to have the class. So we have mean. So you can see that we getting the average flight duration for each those people that used this different sales channel here. You can see that so there are basically some analysis or some relationships that really doesn't make sense. Like if you actually look at it, so it's not everything that you just like compare and check the relationship, right? You have to ensure that there is a meaning, like the relationship you are checking is a meaningful relationship, right? So these are the things that will guide you during your analysis generally. So I've introduced like 2 functions that you use in your EDA. We have your value count, and you have the group by function, right? So you can actually still use your group by function with multiple aggregates, actually, right? You can use multiple aggregate functions. So let's say you want to use mean, median, and mode, you can just use .arg. This .arg function here can take in multiple aggregate functions. So we can put mean, want to get the mean, we also want to get the max, we also want to get the mean, right? So if I run this, you're going to get a data frame like this, which is going to give you on the column aspect the different aggregate functions, and on the row the particular categorical column that you are working on. So let's look at another categorical variable here. We have booking origin. Booking origin. Okay, let's check booking origin. So booking origin. Okay, this basically doesn't really make sense to do this. So these booking origin are basically the countries where the booking was made. Anyways, depending on what you need to do, you probably would want to do that. So let's check change objects. Let's check flight. Okay, we checked flight already. Trip type. Okay, so we have trip type here. We have 3 categories. We have circle trip, we have one-way trip, we have round trip, right? So, and this is the flight duration for each of them. This is the average mean for each of the trip type. This is the maximum flight duration for each of the trip type, and this is the minimum. So all of them have the same maximum, they have the same minimum values for different average values. So you can see how we can aggregate our functions, our variables, and we can group them using this particular technique. Okay, so you can even extend this. You can even extend this to grouping multiple columns actually, right? So I can come here. Let's go back to this. I'm not sure I can use aggregate function with multiple columns. No. So let me just go back here and say mean. Let's say I want to group by multiple columns. I say trip type and say days, I guess. So okay, this should be flight day. Let me get it the particular flight day. So you can see how it is aggregated here. So we have circle trip, and we have trip type here, and we have flight day. So for each trip type, we have the different days of the week. So for circle trip, we have Friday we have the 7 days, right? For one week, we have the 7 days, and for round trip, we have the 7 days. So this is when you want to like group by 2 columns. So it would be a combination of the 2 columns. So if you have like 7 categories for one column and you have 7 categories for another column, so you're going to be having 49 values, right? So it will be 7 times 7 because you're combining each of the columns. Like we are combining a single category for one column with all the categories for another column. So this is basically how you group by more than one column here. So you just pass them into a list, and then with your particular aggregate function. So let me check if you can actually do that for multiple aggregate functions. No. Yeah. I don't think that will work. So as I said before, it's just for one single aggregate function. So either you use mean, or you use max, or you use any other aggregate function that you probably want to use. All right, so that's it for group by function. So this is how we can answer this particular question here. What particular day of the week has the highest flight duration? So now let's look at this last one here. How many complete bookings did we have? That's the first question. And then which sales channel had the highest number of complete booking? So we have two different, if you break this down, we have two different questions. We have a question that will require us to perform univariate analysis. Right, we then have another one here that is going to require bivariate analysis. So between two columns here, which is sales channels and then number of complete bookings. So quickly, let's just check how many complete bookings we did have. All right. So if you go back to your let me go check my DF again. DF complete booking is the last one here. So I'm just going to copy the column name, then paste it. All right, so you can say unique. So okay, just 0 and 1. So basically 0 corresponds to unsuccessful or failed booking, and then 1 corresponds to successful booking. So I will still show us moving forward how we can encode our variable. Like let's say you want to change this 0 to 1 to failed, and you want to change 1 to successful. You can actually do it, right? So, but not for this class. Like we're going to look at that more in data pre-processing during machine learning, right? So, but it's possible for you to change the values in your variable, the categories in your variable, to the one that you feel will be even much better to work with, right? So we have our complete bookings. You're just 0 and 1. So we want to know how many complete bookings we have. So to get that, we can just come here and see DF book. I'll just call this book. So I'll come and say book dot value count. Sorry, I'm just remove this. So you can see from here that we have more unsuccessful bookings and we have less unsuccessful bookings. So we have 41,000 unsuccessful bookings and just 7,000 successful bookings. So if I to convert that to a percentage, normalize equals to true, you can see that 85% of our data had unsuccessful bookings, while 14%, which is 50%, had successful bookings. So this is the answer to the first part of this last question, like how many successful bookings did we have, right? So in this case, we have just 15% successful bookings. So that's a point of concern. So as an analyst, you most likely have to delve deeper to know which particular sales channel was used which particular sales channel was used mostly in this in those records that were unsuccessful. All right. So you can now drill it down, and drilling it down is just simply using group by functions still yet, like doing bivariate analysis on the two columns, trying to know how this relates to this. So what would lead you are the questions that you would ask. So as a data analyst, asking questions is actually very important. Like you need to know how to ask questions, because it's your questions that will direct you, it's your questions that will tell you exactly how to move. All right. So, but in this case, we're just going to stop here and report this as 15%. So 15% of our total of our passengers had successful bookings, while 85% of them had unsuccessful bookings, which is a lot actually. So that you can see that we've been able to answer that question, the first part. So the second part of the question says, and which sales channel had the highest number of complete booking? So now we want to know, we've known now how many complete bookings or successful bookings we have. Now we want to know which sales channel had the highest number of complete bookings. So we already know the sales channel here where we have internet channel and we have mobile channel. So we're going to now use the group by let's come here, group by function, right? So I'm going to come here and so I just want to test our knowledge super. Can someone like just tell us how we can answer this question? Like what particular function and code are we going to use to answer this particular question? Okay, let me just go straight to you. So now we want to like get the total number of complete bookings, right? For for our sales channel. So what we're going to actually do is we're going to come here and say df dot booking complete equal to 1, right? So this is you're performing a logical operation, a conditional operation basically, on all the values of your data set. So you want to know which ones are equals to 1 because those are the ones that are successful. So you can now like assign, just use a df and like enclose them in the larger bracket. So it will return only those bookings that are successful. So you can see now that, just give me a minute here. All right, so sorry about that. So when you've gotten this, you basically created a new data frame that just had the records for only those successful bookings. So now you can now use this data frame to answer that question. So I can come here and say df complete, right? So to get the total number of complete bookings for each sales channel, I'll come here and say df sales or df.groupby rather group no need for group by df dot sales channel and then value counts. So okay, not df complete rather, df complete because this is a new data frame. So you can see now that we have analyze this. Okay, we now have a new information. So for those complete bookings, right, out of the total number of complete bookings we have, I think we did copy this here. So out of 7,391 complete bookings, 6,800 of them came from the internet here, while 589 from mobile, right? So you can see that there is a problem with this particular sales channel. Sorry, there's a problem with. No, what I'm supposed to do here is to get the okay, this actually answers the question for this it answers the questions for this part. It gives the answer for this particular question. Which sales channel had the highest number of complete bookings? So the answer here is going to be internet, right? So, but there's something I want to get. I want to know the particular sales channel that had the highest number of incomplete bookings. So I can come here and just change this to 0 and change this to incomplete. Let me just create another one separately. I'll change this to 0 and change this to incomplete. All right. So I'm going to come here and say the dot incomplete, and let's run this. Okay. So you can see that still yet sales internet had the highest number of incomplete. Although this data set is this is imbalanced, right? Because generally internet has a whole lot more number compared to mobile. But still yet, you're going to like put those into factor to know if the difference is significant. But that's not what we are not going to be going into that in this class. But you can see from here we will have internet having 37,000 incomplete bookings, while mobile having just 4,000 incomplete bookings, right? So mobile is actually still high, right? So out of 7,000 it is booking complete. I want to know the total number initially. So DF, let me get DF. So you can see now, this is how you put them into perspective. Mobile totally has 5,000 records, both book complete and incomplete. But out of those 5,000, 4,000 of them were incomplete or were unsuccessful, right? So if you get the percentage, you're going to see it's going to be actually high percentage. So you would use this 5,000 and 4,000 to get your percentage, and then use this one here and this one here to get your percentage. So from here, you know that, notice that mobile has a higher incomplete booking rate compared to channel. So this is going to be a point of concern as regarding this particular channel. And then as a data analyst, you can make that report, create a bar chart or a graph illustrating how the mobile has a much higher incomplete booking as compared to the internet channel, right? So these are some of the things that you can do during exploratory data analysis. So we've actually just scratched the surface, and this is just like a surface level explanation on what you do normally in ETA. But there are a whole lot more to do, especially this data set actually doesn't really have things that we can work with like that. But for the assignment I'm going to be giving, I'll be giving a different data set, so you would be able to like get meaningful insights, right, from what you're going to be doing. So this is just to show you exactly how you can approach something like this, right, when you come across it. So I said we're going to look at data visualization in today's class. So just an introduction. So I really want us to do that so we can like quickly visualize this output that we are having here. So let me see if I can just bring that out quickly. So I'm sorry if I'm not sounding the same as I do in previous classes. Today is not just it for me. So I just have to finish up with the class because of time. We don't want to start having backlog and all of that. So we're going to just quickly go over data visualization, and I will introduce it to us, and then just show us how we can like incorporate it into our EDA, right? So data visualization is something that isn't new to most of us here. So it's a way of representing information in a graphical format. So if you have numbers, you should know that numbers are not user friendly, right? When you show, let's say, someone numbers and all of those statistics, it might look complex to them. So the best way to help them understand the numbers you are showing them is to represent those numbers in a graphical format. All right. So with that is where we bring in data visualization. So it's a technique in data analysis that help us visualize numbers, right, to communicate trends, to communicate patterns and relationships within data. So we're going to be looking at the techniques, and we're going to be looking at the library that would be used for data visualization. But before we do that, let's just quickly go through some of the benefits of data visualization. So visualizing our data helps in enhanced understanding, right? So I'm pretty sure most of us have seen visuals online. Let's say like during election period or whatever it is that is being displayed. Whenever visuals are being used to convey that particular information, it is easy to understand. Nobody has to start explaining to you that this is this and that is that. Right? Once you see the visuals, you understand that, okay, so red here means this, blue here means this. So because this bar is longer, it means that it is higher than this one. So it is very intuitive, right? So visualizing our data makes communicating information even better, and it helps to enhance understanding, right? So as we have here, visualizing simplify complex data, making it easier to identify patterns, trends, and relationships. All right. So we also have improved communication. So clear visuals effectively communicate insight to a broader audience, even those less comfortable with raw data. And this is very true. So visualizing data has another aim of like reaching a wider audience. So not everybody is a data scientist, and not everybody is the things that you get during your data analysis, the result you get might not be easily understood by majority of the mass. So in situations where your final insights should be communicated to the general public, you don't want to be giving them numbers. You want to show them visuals, and even as naive they might be when it comes to data, seeing those visuals alone would help them understand what is happening, right? It basically improves communication, right? Helps you communicate better to a more broader audience. So visualization also help in informed decision making, right? Obviously, when you present your report to your manager, you present your report most times as a visual or as a graph. So they use a graph to make informed decision, right? Because they see the clearer picture, they understand exactly what is happening, the connection between this and that, and from that they can now make their decision. All right. So visualization also help in data exploration. I think I mentioned this in last class that while exploring your data, visualizing it would help you a lot. To actually help you to explore your data faster and better, right? Looking at numbers and all of that would help, but visualizing some of those things would even be more better. So as I said that whenever you want to perform outlier analysis or remove your outlier, the best way to do that is by visualizing your data. So once you visualize your data, automatically you would notice if there's an outlier in your data or not by simply looking at the visual or the graph that you've created. So these are the different benefits of data visualization, and I'm going to be introducing us to some of the visualization techniques we have. So the first one we have here is line charts, right? We have line chart. This is ideal for this is ideal for time data. So when you want to show how something changes over time, line chart is the best. So remember when we talked about flight day in our data set, so you can actually use line chart to represent that particular data, right? So this particular column here might be the counts of each flight according to day, and this particular row here, this particular axis will correspond to the count, and this particular axis will correspond to the days that you have. So based on what we've discussed before, we talked about x-axis and y-axis. We also talked about axis 0 and axis 1. So when it comes to visualization, this axis that we have here, that is the vertical axis, it is called our y-axis. So this is our y-axis or our axis 1, all right? So this particular one here on the horizontal side is our axis 0 or x-axis. So you just understand how this is being displayed. So the same axis that we've been working with is the same axis that we're going to be working with too in our visuals. So that is it for line chart. We have line chart, we have bar chart, we have scatter plot. So this scatter plot is basically what you would use most times for outlier, detecting outlier, and box plot as well. So, but we have these different ones here. We have line chart, bar chart, scatter plot, pie chart, histograms, heat maps, and box plot. So this box plot is mostly used to detect outliers, as you've seen. You can see here mainly used to detect outliers and assess the distribution of a numerical variable. So you can see this includes all the interquarter range stuff I was telling you about, Q1, Q3, and this middle here, which is Q2 basically. So when we look at the this particular graph in depth, I'm going to be explaining all these things, right? But these are the basic charts that we have that we're going to be using and we're going to be like interacting with. So we're going to look at line chart, we're going to look at bar chart, we're going to look at scatter plot, we're going to look at pie chart, and we're going to look at histograms as well, and we're also going to look at heat maps. All right. So with this box plots too. So I think this is just a good enough introduction to visualization. So the reason why I'm doing this is because I don't want to start taking time again in the next class to introduce. So once we come back in the next class, I just go straight to applying or showing you how to do this using matplotlib and Seaborn as well as Pandas as well. So basically, we are going to continue with this EDA that we have here. So we will actually do more EDA in the next class. I believe next class would be much different because I need to still show us how to do exploratory data analysis with some other functions. So we'd incorporate it with visuals to even make it much better. But just see this as the surface part of EDA, right? So this groupby function and the value count function with the aggregate functions as well that you can use to actually do bivariate analysis and univariate analysis and glean insight from your data. So we'll be combining this thing with our visuals in the next class to see, and you'll see how powerful these different techniques when combined can be. All right, so I'm actually going to be stopping here this class, and I'm actually not going to be taking questions into this class. I'm so sorry about that, but I won't be taking questions. So just keep all your questions to the next class, and we're going to be answering them in the next class. Or you can actually drop it on the group and tag me. Once I go through the chats, I'm going to reply. So please just bear with me on that. I'm not going to be taking questions for this class. So any question you have, you can just put it down on the group Q&A group actually. Tag me. Um, for this particular class, I'm going to answer it. I promise. Right. So it might not be immediately, but I would answer those questions. And if you don't, or if you want to wait till the next class to ask your questions, that's fine. And we're going to trash all of those things in the next class. So yes, I'm going to drop assignment for you to just help you practice what we've like looked at so far, right? And also the poll for assignment correction would be, I'm going to do that immediately after the class now, so I don't forget. So I'm looking at Wednesday or Friday. I would yeah, I think I'm going to just make those options make it those two options. Wednesday, well, let's just say Wednesday, Thursday, Friday, right? Any of those days. So it's going to be in the evening actually. So it's going to be in the evening, and the time is going to be either 7 p.m. or 8 p.m. Right? So the time would also be an option as well. So I'm going to drop that, and um, hoping to get um, your reactions to it. So take the class already, but that's fine. So we're going to meet again in the next class, and I hope to see you then as well. Thank you very